Hi students, welcome to HSC Earth and Environmental Science and Module 5, Earth's Processes. This is video number 7 and we're going to be looking at the importance of cyanobacteria. So we're moved into the second little section now, and so we want to try and look at some of the implications of a few of the changes that we've seen already. And primarily what we want to do is analyse the geosphere, the atmosphere and the hydrosphere in terms of the changes that have happened as a result of photosynthesizing cyanobacteria. So now you should be able to identify these important early organisms, the early photosynthesizers, to be able to contrast the impact of these organisms and the processes that were being carried out on the chemical changes that were occurring in the oceans, in the hydrosphere and also in the atmosphere, and maybe extend that to some of the other changes that may have flowed on from that initial increase in oxygen levels. So this is our second inquiry question. How did the changes to the biosphere affect the Earth's geosphere, atmosphere and hydrosphere? First of all, we need to look at changes in the biosphere. The original atmosphere was an anoxic atmosphere, and it was the introduction or the evolution of autotrophs. Specifically, we talked about the cyanobacteria responsible for the formation of stromatolites that were carrying out the first photosynthesis and were starting to release oxygen. Now, this increase in the number of photosynthesizers, as we saw the number of cyanobacteria increasing, so we saw increases happening in the amounts of oxygen that were being released. A lot of that oxygen was in the oceans, and some of that was combining with iron that were responsible for the formation of these banded iron formations. And some beautiful examples that you can see in Western Australia, in Dales Gorge, which is one of the sites that is famous actually for these beautiful red iron-rich bands in the rocks. And we think that was a result of a lot of the iron that was being precipitated as a result of the oxygen production of these early photosynthesizers. But as the iron started to decrease in the oceans, so oxygen started to then bubble out of the oceans and into the atmosphere. And so that created changes in the atmosphere as well. What was particularly important was the ultraviolet radiation, which was going to interact with oxygen molecules in the atmosphere to produce ozone. So going from O2 molecules to O3 molecules. And these O3 molecules are the ozone molecules, and they're the ones that were responsible for building up this ozone layer, which ironically, as it was ultraviolet radiation that created sufficient energy for the oxygen to react to form ozone, that ozone would then actually block ultraviolet radiation from reaching the Earth. That was an important step because it was kind of the point where we started to talk about it shifting from an anoxic environment to an oxic environment, levels of oxygen much closer to what they are today. And of course that had irreversible changes on what was happening to life on Earth. There's a really nice diagram in your textbook, Earth and Environmental Science in Focus, and it shows not just the fact that these cyanobacteria that were responsible for the stromatolites, so the cyanobacteria were our photosynthesizers, and these were producing these stromatolite structures. What they were doing was increasing the levels of oxygen, and that was reacting with iron that was in the surface. Obviously, these were very close to the surface waters because of their need for light. So they were able to release that oxygen. That oxygen was combining with iron and precipitating out of the ocean. But we also had movement that was actually bringing some iron from other parts of the ocean back up. And we looked in Year 11 course at those deep ocean currents and how they enable materials to circulate, particularly salts to circulate around the globe through the great conveyor belt. And so here we were getting some of these oxygen poor waters with large amounts of iron moving into these more shallow waters and precipitating out. So that's why we have such a large number of these beautiful banded iron formations or red beds in rocks of that sort of 2 billion year old age in the Earth's crust. The other thing that was happening, of course, as the oxygen levels were building, as the formation of the ozone layer was happening, as the oxygen levels were increasing and moving us from an anoxic to an oxic environment. So we were then able to have an increase in the types and the number of organisms. That additional extra oxygen meant more respiration, which meant more energy. Organisms could be more energetic. They could perhaps be hunters. So we saw a real change in the fauna that was happening as a consequence of this increase in oxygen that was happening in the atmosphere. We do know when we compare the energy associated with anaerobic respirers and aerobic respirers that we see a significantly more efficient energy efficiency in the aerobic respiration. And so that meant that these organisms that were now able to carry out respiration in the presence of oxygen because of all this extra oxygen meant we had this increase in complexity and also an increase in the number of different organisms that were around. This, in fact, was such a significant process that we really couldn't go back. You couldn't go back to the original environment on the Earth. Once these processes had started, carbon dioxide levels in the atmosphere were dropping. There were also reductions in the amount of methane in the atmosphere, which was also dropping, what we called a reducing atmosphere, no oxygen there. And now we've got these oxygen levels on the rise. And so that made some significant changes to the atmosphere as a result. When we study the fossil record, what we see is that there were probably a couple of occasions in which the levels of atmospheric oxygen took a really big jump. The first of those was the end of the Archean and the start of the Proterozoic. So we're looking here at a time period of around about the 2 billion year old mark, and this does correspond to where the range of the red beds or the banded iron formations are. And this has been referred to as the Great Oxidation Event. This was a proliferation of these stromatolites, of these cyanobacteria, and what happened was the levels of oxygen were what we estimate to be around about 10 to 20%. Now this is from zero, 10 to 20% of the current level. So if we're looking at about 20% now, we're looking at a tenth, so 2 to 4% oxygen at that point. But we did find another spike, so an increase, and then another increase as we reached the end of the Proterozoic, called the Neoproterozoic oxidation event. This event, which again corresponded to a dramatic increase in plant life, in photosynthesizers. And when we talk plants, we're talking very simple plants, algae, but the increase in the amount of photosynthesis that was happening between about 600 and 800 million years ago is what created those additional jumps in oxygen levels in the atmosphere. This was also pulling out carbon dioxide, and we do find you do find some references to the snowball Earth, which is a period of time where those greenhouse gases, we're aware that carbon dioxide and methane, for example, are two very important greenhouse gases that we're concerned about in the current age. They were in very high concentrations in this early Earth atmosphere, but the fact that the carbon dioxide was being withdrawn by photosynthesizers, the fact that oxygen levels were increasing, and also that the oxygen and the methane combining together too, chemically, was significantly reducing the concentration of those greenhouse gases in the atmosphere and increasing the levels of oxygen. And so that meant that we had a slight change in the way that the sunlight was reaching the Earth, in the way that the long wave radiation that was reflecting off the surface of the Earth was being trapped. And as a result of all of that, we did have a cooling that was occurring just prior to this particular point in time too. So we've got some significant changes in the oxygen levels as a result of these certain and quite important events. But what you need to do is you need to specifically link the changes that were happening in terms of the growth of cyanobacteria and the changes that were happening in the spheres. So I always find that these sorts of tables are a really useful tool, not just for you for study, but also to help organize your notes. So we need to look at the three spheres. What's happening? Well, in the geosphere, the main thing that was happening in the geosphere was the formation of these banded iron formations. That's some specific detail that we can see about changes that were happening on the Earth's surface. The other thing that was happening is that the increase in the oxygen levels was also creating some additional oxidation in some of the surface minerals. So some of the minerals that had been very stable in the atmosphere previously now were interacting with these higher levels of oxygen and undergoing a chemical weathering process, a chemical breakdown. And so that increased the number of hydroxide and oxide minerals, clay-based rocks that we see around that period of time from the Proterozoic. So we've got a couple of different areas of evidence, particular types of minerals, particular types of deposits that indicated those higher levels of oxygen, the result of cyanobacteria and their photosynthetic activity. We've talked about the atmosphere, so we probably don't need to talk about that again. I've mentioned a little bit about some of the factors that might have led to the snowball Earth, and also the fact that we had quite a change in the composition of the atmosphere as a result of this process of photosynthesis. And in the hydrosphere, the main thing we've been looking at is the fact that the cyanobacteria were in the shallow waters of the oceans means that the oxygen levels in the hydrosphere, in the water, changed first. That is going to affect any of the material that's in the ocean that's going to interact with oxygen, the primary one of which was iron and the formation of iron oxides, which sank, created those beds, and it was a result of that ended up with the buildup of oxygen being released from the oceans and building up in the atmosphere. And we also talked about the fact that there was a bit of a shift, that loss or the lowering of the carbon dioxide levels in the atmosphere resulted in a shift, and what we call an equilibrium shift is a chemical concept. And you can see this sort of an effect every time you open a bottle of soft drink. So there's a certain amount of carbon dioxide that sits above the liquid in soft drink. You undo the lid, that escapes, and so some of the bubbles that have been dissolved in the solution then bubble out to try and take the place of those ones that have gone, and so you see that as bubbling every time you unscrew the lid. And we also know that if you continue to do that, there will be a point where it'll be flat, where there's no more carbon dioxide in there that's coming out, or there's so little that you can't actually see it coming out as bubbles anymore. Now, the other thing with that is that carbon dioxide in water produces a slightly acidic solution. So when you remove that carbon dioxide, you make the water a little more basic. And that did change the pH of the oceans, but the other thing that it did was it created a situation where we could have some really nice growth of carbonates. And carbonates are part of the skeletons of coral reefs and also part of the skeletons of a number of different types of animals. So this, again, was shifting the whole of the Earth's environment in a direction from which it couldn't come back, and creating environments that we now see occupied by a huge range of different organisms. So using these sorts of tables, I think, is a really nice way of being able to summarize all the key information, and you'll probably be able to summarize it better than I have here. Just wanted to give you a nice overview for each of these different relationships between the increase in cyanobacteria and the effect on each of the spheres of Earth. Thanks for watching.